Hello everyone. Today we are going to derive the quadratic formula. The quadratic formula can solve any quadratic equation, and it is often taught to middle and high school students who are forced to memorize them. Now we will finally see where it comes from. We are going to take a generic equation, and by using the completing the square method, we will derive the quadratic formula. Our generic quadratic equation will be of the form a times x squared plus b times x plus c is equal to 0. This means that a will be the coefficient of x squared, b the coefficient of x, and c the constant term, which is common practice. The first thing we will do is divide both sides of the equation by a, which gives us x squared plus b over a times x plus c over a times x plus c over a is equal to 0. Now the coefficient of x squared is 1. It will be easier to complete the square. The first thing we do is take 1/2 of the new coefficient of x, which is b divided by 2a. We now consider x plus b over 2a squared, and we can now expand. We expand the terms, which gives us x squared plus b over 2a times x plus b over 2a times x plus b squared over 4a squared, which simplifies to x squared plus b over a times x plus b squared over 4a squared. We can then subtract b squared over 4a squared to get rid of the constant term, which leaves us with x squared plus b over a times x. We can now add c over a to both sides to get expressions equivalent to the left-hand side of our original quadratic equation. This gives us that x plus b over 2a squared minus b squared over 4a squared plus c over a is equal to x squared plus b over a times x plus c over a. This is just the left-hand side of our original quadratic equation. Therefore, we can use this other form and set it equal to 0 and solve from there. Firstly, we will combine all the constant terms and then set our expression equal to 0. This gives us that x plus b over 2a squared minus the quantity b squared minus the quantity b squared over 4 squared minus c over a is equal to 0. We now go about solving it normally. First, we bring all the constant terms to the right side by adding b squared over 4a squared and subtracting c over a. This gives us that x plus b over 2a squared equals b squared over 4a squared minus c over a. Now we can multiply both sides by 4 times a squared. Because the left-hand side is squared, we multiply the inside of the square by 2a. This gives us that 2a times xb all squared is equal to b squared minus 4ac. Now you may be beginning to see similarities to the final equation. We have the discriminant, b squared minus 4ac, on the right-hand side, and a 2a coefficient on the left-hand side. Now we are nearly there. Square rooting both sides gives us that 2a times x plus b is equal to the positive or negative square root of b squared minus 4ac. We now subtract b from both sides, giving us 2a times x is equal to negative b plus or minus the square root of b squared minus 4ac. Finally, we divide both sides by 2a to get that x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Hence, we arrive at the famous formula you have all had to painstakingly memorize. So now you know where the formula comes from. It is a good idea to memorize it for now, as although you can derive it, it is not practical to waste a couple minutes deriving it on a test. However, hopefully this video has given you some appreciation for where the formula comes from and helps you understand the principle behind it, as it initially seems very random to most people. Thank you for watching.